Hi guys, welcome back to my YouTube channel. My name is Khaliltronics. In today's video we are going to take a recap of differential calculus from basic to first principle, differentiation using past principle, sum rules, product rules, chain rule and quotient rules. So as we have made a lot of videos concerning differentiation, so it is there on our playlist. You can easily go there and search and get your desired video. So without wasting time, we're gonna proceed with the origin of differentiation, that's from the gradient. So from the diagram above, this figure says that we have 2 points. We have straight line point A, that's straight line A to B, and then we have 2 points, that's point P and then point Q. So from point Q, P, I mean we have x1, y1 and x1, and for Q we have x2 and y2 respectively. So here is x2 and here is y2, here is y1, x1. So according to gradient, says the change in x, that's gradient of the straight line is equal to change in x, change in y, I mean by changing what, x. So that's changing y, y2 minus y1 over changing x, x2 minus x1. So if the point 2 point is given, that's point P, let's say is 2, 3, and point Q is, let's say 4 and 6. So you were asked to find the gradients. Just take here is x, here is y, just take the difference, that's 4 minus 2, we have sorry, I mean it's changing y, that's 6 minus 3, which is 3, and then 4 minus 2, which is what, also 2. So the gradient is what, 3 by 2, as what, changing y by what, changing x. So according to this, since the gradient is described by this and we have the derivatives, that's differentiation, as what, changing, that's dy by dx. So actually this is from the straight line graph we derive the differentiation. So we are going to take a look of differentiation using some rule, and then product and quotient, and then using past principle. Okay, so taking a look at this small table, we have a function such this function is given as y. We have a function like this, y, and then we have the derivative. So if you have x of n, x to the power of n, like we have, let's say x power n, and we were asked to find the derivative of it, is simply the power, we multiply it by the coefficient. So in this case we don't have coefficients, the coefficient is 1. We can simply say n times 1, that's our coefficient, and then the x n minus 1, so will be nx to the power of n minus 1. So as this is shown, and then differential of constant term, if you have, let's say you have 6, 7, 100 and so forth and so on, if you have differential of constant, is just 0. So if you have differential of 1000, the differential of it is what, 0. So if you have x raised power of n, the differential of it is just this power, that's n, multiplied by the coefficient, that's a, making an, and then take the power and subtract 1 from it, that's n minus 1. And then for sine, differential of sine is just the costs, and then differential of cos is minus sine, differential of tan is what, tan square x, and then differential of exponential of x is what, exponential of x. Meaning that if you have, let's say, x differential of 2x, that's y is equal to differential of 2x, and you were asked to find dy by dx, that's differential, you can simply say this, the power, this the that's 2x, just the coefficient of x should be multiplied by the coefficient of exponent, that's 1 times 2 making 2, and then exponent itself, then 2x. so that's how the differential of exponent is. So as we explain the table, this is how to take the integral. So we are going to take a look at simple equations so that we can easily understand. So in this case, if you have a function, let's say we have y is equal to let's say 5x square, then using first principle, using formula, we have, if you have ax n power minus 1, if you have x power of n, if you have an x power of n, the differential of this should be give you this. So the question is given as y is equal to 5x square. So to find the differential of this function, we can say 2 times the coefficient is 5, that's in parentheses, and then x, that's we take the x again, and then 2 subtract 1 from the 2, that's 2 minus 1, then we can say 10x raised power of what, 1, which is what, 10x. Similarly, if you have y is equal to let's say 3x square, we can, let's say 3x power 4, we can say 4 multiplied by the coefficient, that's 3, then x raised power of 4 minus 1, which is what, 12 x raised power of 3. So this is how it's work. This is using formula. So we're gonna move with product rule, sorry, I mean sum rule. We're gonna take sum rule. So for the sum rule is just to take the individual of, let's say the question is given as y is equal to 2x, the question is given as 2x raised power of 5 plus 7x raised power of 3 plus 9x raised square plus 7x plus 6. So this is the sum rules. So if you were asked to find the derivative of this, that is to find dy dx, just simply take the derivative of each terms individually. So the derivative of first term is what, that's 2 multiplied by 5, then x raised power of 5 minus 1, and then for this we can say 7 times what, 3, then x raised power of 3 minus 1. Then for the other term we can say is addition between them. For this time you can see 9 times what, 2, then we have x power 2 minus 1. Then for the next time we have the 7x raised power of 1 minus 1. Then if you multiply by the coefficient is 1 times 7 is 7, and then differential of constant term is 0. So here you can say 2 times 5 is 10. Here is 5, so 2 times, yes, multiple between them, 2 times 5 is 10. You can say 10x raised power of what, 4, and then plus 7 times 3, 2 and 1, x raised power of what, 2, x raised power of what, 2, and then 9 times 2 18, x raised power of 2 minus 1 is just x, and then plus 7, x power 0 is 1, then 7 plus 0. So the answer should be so it's just to what? It's just to, there's no 0 since 0 is negligible, so 0 will be considered. Then we can say just plus 7 since x power 0 is what, also 1. So this is the final answer. So the sum rule is just to find the derivatives of each terms separately, then merge it together. So this is sum rule. So we are going to take differentiation using past principle. That's next. Past principle. So assuming the question is given as, let's say, y is equal to 2x squared plus 5, to find what, dy by what, dx, using what, first principle. Or let's say, let's find y is equal to x squared, using to find x squared or x power 3 using past principle. So it's just the same procedure to solve. So all you need to do is wherever you find or see x or y, you just replace it as what, x plus the increment. It's just to add an increment, and then the increment is just changing y. Like if you see a y, you should add increment to it to make it y plus what, changing y. If you see x, just substitute it and put x plus what, changing x. So taking our question, our main question is y is equal to 2x squared plus 5. So all you need to do is just, all you need to do is just apply procedure that I have said earlier. So we have y, we just add an increment, that's plus del y, as del y is equal to 2 into, we have x as x squared, so we can say x plus del x square, then plus 5. So whichever the question is, just to add, wherever you see x, add increment, wherever you see y, just add increment. So we have y plus del y is equal to, we are to open a parenthesis. If you have a plus b whole square, you can say a square plus twice of ab, then plus b square. So here we can see we have 2 outside the parenthesis. Here we have, can see x square plus twice of the x and del x, that is x del x. Here is del x, and that's changing x, plus del x square, del square x. That's, you just need to open the bracket, the square. So plus 5, then we can simply say 2x square by opening the parenthesis, plus 4x del x, then plus 2 del square x plus 5. We can remove this. So as here we have y plus del y. So our aim is to find the change in x, is to find this. So we should we'll make the, that's the derivative, that we should make this to be subject first. So we can say del y is equal to 2x squared plus 4x del x, then plus 2 del square x plus 5, then minus this y, then we can say minus y, and the value of y is given initially as what, 2x squared plus 5. Then we can substitute, we can then say 2x squared plus 4x del x, then plus 2 del square x plus 5, then minus, we have y as 2x squared plus 5. Then if you open the parentheses, we will have 2x squared plus 4x del x plus 2 del square x plus 5 minus 2x squared, here is minus again, here is minus 2x, here is minus 5. So minus 5 goes with plus 5, minus 2x goes with what? Plus 2x. So we'll have what? We'll say we'll have 4x del x plus 2 del square x, and then what? That's what we have. So here we have dy. So from here we are trying to find dy dx, so we can say dy, that's change in y, is equal to this. So we can factor out dx here, saying dx is equal to outside the parentheses, that's plus that's into 4x, that's into 4x plus 2 del x. So looking at here, we want to find dy dx like we are trying to find dy by dx. So we can simply say, we can simply divide it by through by coefficient of x, that's divide through by dx. So we can say by dx, then we can say dy. So we can also say, let's proceed, we can say dy by dx, that's from here we have what, 4x plus what, that's plus 2 dx. So we can also say, taking limit, since here we still have dx, so we have to eliminate it, since we only need what, this dy by dx. So we can take limit, we can say limit d what, dx or del, okay, or del x to be what, equal to what, 0. So therefore our dy dx should be equal to what, 4x plus 2 into what, 0, since this become what, 0. So we can say dy by what, dx is equal to what, 4x. So this is a solution, final solution. So if you want to solve it using ordinary method, you can say the question is given as what, y is equal to 2x squared plus 5. So if you want to just find the differential using ordinary method, not past principle, you can simply say dy by dx is equal to 2 times the coefficient, that's 2, then x to the power of what, 2 minus 1. Then for this other term is constant term, which is 0. Then from here we can say 2 times 2 is 4, that's 2 x raised to the power of 2 minus 1 is 1, so it will be for 1, then is equal to what, 4x. So as you see, this answer is correspond to this answer. So here is using past principle, here is using what, ordinary method, that's using formula. So we'll take a look at product rule for the next one. So this is the product rule, and then the formula of the product rule is y. Let's say if you have y is equal to ub, and then to find the dy by dx, so this is the formula. So assuming that the question is given as y is equal to 2x plus 2x squared plus 7, and then another function is 4x power 3 plus 9. So as you see, this is the product rule. So if you want to find the derivative of this, you have to apply a formula, and the formula is given as this. So as you need to understand, if you have y is equal to ub, so all you need to do is to just keep this one, the first one, keep it constant, so like this, and this is it, and then differentiate the second one. So we differentiate the v with respect to s, and then for the second one just add plus. For the second one, leave this one constant, that's to make the v is constant. Don't differentiate b, that's to make it constant, and then differentiate the v u. So in general, if you want to differentiate the product rule, you can simply say take this one constant, that's u, differentiate b, that's derivative, and then plus take b constant, then differentiate u. So that's how to find the derivative of product rule, that's dy by dx. So let's take a look of these questions. We have y is equal to 2x squared plus 7, and then the other part is 4x 3 then plus 9. So we can say let this to be equal to u, and then let this to be equal to b. So we are not going to use the formula. I'm gonna just use the shortcut method to solve, since we have already solved numerous questions in our playlist. Here is just a recap. So all you need to do is to just trying to show you some quick methods. So to find dy by dx of this, we can simply say we can leave this one to be equal to constant, so we leave this, that's for u, we can leave it to be equal to constant, so we can leave it as constant. We have what, 2x squared plus 7. This we leave it, we happen to differentiate it, that's constant, we leave it as constant. Then to differentiate this, so to differentiate this, we can say differential of this, we have 3 times 4, that's 12, then x power 3 minus 1, which is what, 2, and then plus differential of constant term, that's differential of 9 is 0, so no need to put it, and then plus the first one, we take this one constant and differentiate this. So then the second one, we would take this one constant, you can say this one should be constant, that's 4x power 3 plus 9, and then differentiate the other one. So now we have to differentiate this one, this 2x squared plus 7. So differential of 2x squared, we can say 2 times 2, which is what, 4, so no need to put it, we can say just 4, then x, 2 minus 1 is just 1, so it's just x, then differential of what, 7 is 0, so no need to compute it. Then here is the final solution, so it's just open a parenthesis. If you like you can leave it like this. So we will have 12x squared into 2x squared plus 7, and then the other part we will have 4x into 4x squared plus cube plus what, 9. So this is how it should be. So but initially we have to use the formula, but this is the shortcut method. If you want to see more details of the video or product rule or some rule, you should go to my playlist and find it. So we'll take another question and see how it is. One question on product. So we are going to take another question. So like now, the question is, another question is given as y is equal to x square cos what x. So as you see, this is the function on a function, so this should be what product row. It's just like x square into cos x, so it's just function on a function. So what you need to do is to just take one constant, differentiate the other one, take another one constant, differentiate the other one. So we can say dy by dx is equal to, we'll take this one past constant. That's the formula is just like dy by dx is equal to u differentiate the other one, take b constant, differentiate u. So we can just take x square as a constant, so we have x square, then differentiate the other term. Differential of course is minus sign, then we can see minus sign, and then plus take the other part constant. We should leave this one to be equal to constant, that's cos x, and then differentiate the other one. The other one is x square. Differential of x square is what? 2x. Then we can say we have minus x square, yes, minus x square sine x plus 2x cos x, right? So what you have is just 2x cos x minus x square sine x. So another question is y is equal to exponential x then sine x. So we had to differentiate this using product rule. We can just leave this one to be constant, that's exponential of x, differentiate this. Differential of sine is what? Cos x, and then plus take the other one to be constant. Initially we take exponent to be equal to constant, but at this time we should take sine to be equal to what? Constant. So sine of x to be constant, and then differential of exponent is what? Just the exponent. So we will have dy by dx as what? Exponential of x cos x plus exponential of x sine x. So this is how the product rule is work. So we are going to move for the chain rule and then the other part. And then for the chain rule, it's very simple. It's just if you have let's say y is equal to some certain function, let's say you have u power n, then for this you can say the formula is given as this dy by dx is given as dy by du, then du by dx. So it's basically like du can cancel du to make it what? Dy by y dx. So it's just the formula for the chain rule. So let's take a look up at one question. So y is equal to 3x plus 5 whole power 4. So as you see, this is not just some row or product row, is the one with power, so it's like chain rule. So to get this, you can firstly let all this one to be equal to what? U. So you can say u is equal to 3x plus 5. Then since u is equal to this, then the equation will be, the y will be equal to u power what? 4. So to find dy by with respect to what u, since here the y is what is consisted of what u, not x, so you should get what derivative of x with respect to u. So derivative of x y with respect to u will be 4u 3 minus 4 minus 1, which is what 3. So we'll have this, that's 4 power 3, and then we have find this, that's dy by du, then the other one du by dx. Since u is this and the u, it consists of what variable x, variable of x, so we can find the what du with respect to what x, which is equal to what derivatives of this is what just 3, and then derivative of 5 is what 0. So by putting on the formula dy by dx is equal to dy by du, we have it as what 4u power 3, then times multiply by du by dx from the formula, that's 3. So but our value of y remain the same, so we have to substitute. Our u is what 3x plus 5, then power 3 times what 3 also, then we can say 3 times 4 making 12, then times the whatever inside the parentheses, that's 3x plus 5 all power 3. So this is how it should be. This is how it should be. So in general, the shortcut is very easy. If you have this, you have y is equal to 3x plus 5 raised power 4. So all you need to do is to just find the differential of parentheses. The differential of parentheses, whatever inside the bracket, find the differential of it. We can say differential of this is only what 3. This one has differential of constant is 0. So we can say the differential of parentheses is what 3. And then take the whole parentheses with power and subtract what 1 from it. We can also say we have what 3, okay, so the differential of the parentheses is 3, and then this power should be at the time multiplied by the parentheses, that is this 4 multiplied by this, the way you should do it as normal differentiated, and then take the whole this and subtract 1 from the power, then 3x plus 5 power 4 minus 1. So all you need to do is just simple, take the differential of this. The differential of this is what is just 3, and then this power should multiply by what you get at the differential of the parentheses, that is times 4, and then tell the whole expression and then subtract the 1 from the power. So that's how it is. It's just okay. Then 3 times 4 is 12, and then 12, and then 3x plus 5 into what 4 minus 1 is 3. So as you see, it's similar with the one we did in the formula. It's similar. So assuming that another question is given as y is equal to let's say, let's take another one. Y is given as, let's say, 2x power 4 plus 12x plus 4x square whole power what, let's see, 6. So you have to find the differential of this. So simply you can just say differential of this with respect to x. We can take the what differential of the parentheses, that's whatever inside the bracket, the whole this, you should take the differential of this. So differential of the first term is what 4 4 times 4 times 2, I mean is what 4 times 2, that's 4 multiplied by the coefficient is what 8, and then x power 3, then differential of this is 12, and then plus differential of this is what 8, that's 2 times 4 is 8 into what, then just x, since we subtract 1 from the 2. So it's just what sx. So this is the differential of the parenthesis. Just this should be multiplied by the differential of the parenthesis, multiply by 6, and then take the whole this and subtract 1 from the 6. Then we'll take the whole this, that's 2x raised power 4 plus 12x plus 4x square, then power 6 minus 1. Then the expression should be 6 into x power 3 plus 12 plus 8x, then the other terms should be 2x power 4 plus 12x plus 4x square whole power what 5. So this is how it should be. This is for chain rule. We're gonna move for the what quotient. I think the quotient is the last one, so we're gonna take quotient rule. So we're gonna move for the, is this quotient rule? So for quotient rule is very easy. It's just like a product rule, but the only difference is just division. So quotient rule, that's quotient rule, quotients rules. So assuming like we have, let's say for the product rule, we know for the product rule we have y is equal to what, ub, and then for the chain rule we have y is equal to u over b. So it's just, this one is just like product, and this one is just like division. So the formula is given. If you have, let's say y is equal to u by v, then dy by dx should be equal to what, b du by dx, then minus u db by dx all over b square. So this is the formula. The only difference at the product rule, you can take each term, you can take any terms past, but this one b should be at the first, since here is subtraction between them. So all you need to do is to just differentiate v. If you have something like this, just differentiate v, differentiate u, and then substitute in the given formula. So let's take example. The example is given as let's see y. The example is given as 2 exponential of x then over x squared. So as you see, this is the division. So you can say let the top one should be what, u, and then the bottom one should be what, v. So from the formula you need b and u, and it's already there. So you need derivative of u with respect to x, v with respect to what, u with respect to x, I mean. So we can say let's you can say let u to be equal to what, 2 exponential of x, and let what, v equal to what, x squared. So we can find du by what, dx. So du by dx is what, the coefficient of this x is 1, so no need to multiply. Even if we multiply 2 times 1 will still remain what, 2. So you can say 2 exponential of what, x, that's the differential of it. And then dv with respect to x is just what? 2 times 1, that's 2x. So just plug it, substitute this in the formula. So dy by dx is equal to, so the first is what? V. You have to take v. Our b is what? X square, and then the derivative of what? U, that's du by dx is what? 2 exponential of x, and then minus, then u, this u should be just taken, and the u is given as what? 2 exponential of x, that's 2 exponential of x, and then multiply by what? dv by dx, and dv by dx is 2x, so we can substitute. So here then over what? B square. What is our v? Our v is x square, so we can say x square what? Power 2. Then we can substitute, we can simply simplify the function, saying that x square, that's 2x square exponential of x minus what? 2 exponential of what? You can say 2 times 2 is 4. You can say 4 less, we can say 2 times 2 is 4. 4x exponential of what? X, then divided by what? X power 4. So this should be what? We can factor out x. You can say x into what? 2x what? Exponential of what? X, then minus 4 exponential of what? X. Then we can have x power 3 dot x, then x goes x, then the final answer should be 2x exponential of x minus what? 4 exponential of x all over what? 3x. So this is the final answer. Let's take another question. Another question is what? Y is equal to x power 3 over what? Sine x. X power 3 over sine x. This should be, we have, let's u to be equal to what? X power 3, and then b equal to what? Sine x, and then find the u with respect to what? X. U with respect to x is what? 3 times the coefficients 1, that's 3 x power what? Minus 1 should be what? Square. Then d what? V with respect to what? X should be what? Differential of sine is what? Is just cos x. So we should apply this to our formula, which is dy by what? Dx is equal to what? B dot du dx minus u dot db dx over b square. So we have what? V as what? Sine x, and our du dx is 3x square, and then minus u, our u is x cube, and then db dx, our db dx is cos x, and then all over b square. Our b square, that's sine x square. So simple meaning, we can just say 3x square sine what? Sine x minus x cube cos x all over what? Sine what? Square x. So this is how the answer should be. Here is what? Dy by dx. So this is how the answer should be. So I think we have finished with differentiation using sum rule, product rule. I think we have done with what we have done with sum rule. That's sum rule. We have done with product rule. we have done is 10. We have done with quotients, and we have done with differentiation using past principle. I think we have done is all this, so I think it's just remain one thing to cover, differentiation. So another question is given, another types of questions is given as if if y is equal to 2x raised to power 5 plus 4x raised to power 4 minus x cubed plus 3x squared minus 5x plus 7, find an expression for dy dx and find the value of dy dx at x equals 2. So basically what this means, what does that question mean is to find the derivative of this function first and then substitute the value of x as 2 for the given derivatives after you find derivative. So first all you need to do is to just differentiate the function. So y is given as this, so to find derivative of the function above, you can say dy by dx is equal to, so we have this is raised to power 5, so multiply by 2, we have what, 10x raised to power 4 plus, and we have 4 at the power and the coefficient is 4, that's 4 times 4 16, making 16. X raised to power of 3, 4 minus 1 is 3, and then the next time is x cubed, the next time is x cubed, you can simply say minus 3x squared, and then the next time is what, is 3x squared. We can multiply the power by the coefficients, that's 3 times 2 making 6x, and then the second to last terms, that's 5x is just the minus 5, and then the last terms is 7. Differential of constant term is 0, so you can add 0. So our answer for dy by dx is just equal to 10x raised to power 4 plus 16x raised to power 3 minus 3x squared plus what, 16x minus what, 5. So after you find this, then the next question says, and the first question is, it says find the expression for dy dx. That's the expression we have done is that, and then the next question is say find the value of what, dy dx at x equal to 2. So we should find the value of this expression when x is equal to 2. So we can just say x is equal to 2, so substitute x as a 2 in the above equation. So it's just easy, anywhere you see x, just replaces at 2. Then dy dx, this is the first question. Then the second question is just to substitute, and dy by dx is just 10, x is 2, the raised to power 4 plus 16, our x is what, 2, the raised to power 3, here is minus 3, x is 2, raised to power 2 plus what, 16 into 2 minus 5. So by solving the answer, maybe using calculator or whatever, you will have what the value of this. You can say 2 power 4 is just 16, and then plus 16 h minus 3 into 4 plus 16 times 2, then minus 5. So after computing the value, the answer should be equal to sorry, I think we have made some, here is just, I think here is just 6, it's not 16, so here is just 6. but let us confirm and see. Here is justices is what the 2 times 3, this term 2 times 3 is 6, then x, so it's just here is 6x, so it's not 16, it's just what 6x. So here it should be what, it should be 6 also, so here it should be 6 also. So the answer should be 10 times what, 16 plus 16 times 8 minus 3 times 4 plus 6 times 5 times 2, then minus 5. So after computing all the answer should be, the final answer should be 283. Then dy by dx is equal to what, 283 at what, x equal to what, 2. Then you can see f of what, 2 is equal to what, dy dx. So at what derivative of when x is equal to 2, the derivative should be equal to what, 283. So I think this is for the differentiation. So this is just recap. Our normal videos is there on our playlists. You can go through it. It's very simple, and we solve it in such a way that everyone could be able to understand. This is just shortcut, but in our normal videos in our playlist we have solved it in detail, step by step, so that everyone can be able to understand the concept. So thank you so much for your time. We really appreciate, and don't forget to subscribe, comment. Thank you for watching.